Alright guys, this is an honors-only podcast. If you're in one of my standard classes, you don't have to watch this. You can if you want to, but you don't have to. Today we're going to be talking about hybrid orbitals. So this is something that you'll really get into detail about when you go into AP chemistry, but I want you to be aware of this phenomenon that actually happens. And this is when you have two atoms or two or more atoms bonding, you take the orbitals and you combine them together. So if we're looking at methane, CH4, the molecule is going to be a tetrahedral shape and it's going to bond with 4 atoms. So really it needs 4 spaces for electrons. And the electron configuration of carbon is 2s, 2p2. So when we bond the carbon with the 4 hydrogen atoms, those orbitals, those s and the p, actually come together and make something different to actually accommodate those electrons. So the s orbital will combine with 3 p orbitals so that there's 1 electron in each, and then it can bond with 4 atoms. So then each bond, it'll allow the 1 electron that it's sharing from the other atom to come into the orbital. So we say that this one is sp3 hybridized. So right here's the CH4, and this is the normal configuration for methane. But what it does is it actually takes the s and these 3 2p orbitals and it mixes them. So then we have 4 sp3 orbitals. So it's basically just taking the s, which is the sphere, and then the p, which are dumbbells, and just combining them together. Okay, so this is the easiest way to figure out what type of hybridization is going on, is by counting the pairs of electrons. So when I say pairs of electrons, what I mean by that, and you should write this down somewhere, when you count pairs of electrons, you count the lone pairs, and then single pairs would count a single bond, but a double and a triple counted as 1. Equals 1 pair of electrons. Okay, so if we have 2 pairs of electrons, it's said to be sp hybridized because it's going to take 1 s orbital and 1 p orbital and combine them together. If we have 2 or 3 pairs of electrons, we're going to take 1 s and then we're going to take 2 p orbitals, and then it's sp2. If we take 4 pairs of electrons, we're going to take 1 s orbital, 3 p's, and then it's said to be sp3. So if you notice right here, we've got 1 s, which we've got 1 s orbital that we mixed with 3 p orbitals, so it's sp3. So right here, 1 s, so it's s, and then 2 p's is p2, so sp2. Okay, so when we have 5 pairs, we're going to take sp3 d. So that's 1 s, 3 p's, 1 d orbital. And we would stop with p3 because remember, p only has 3 orbitals. When we do the electron configuration, the orbital diagrams, there's only 3 boxes in p. So the next one up would be d. So an sp3d would have 5 pairs of electrons, and it's 1 s, 3 p's, and 1 d. 6 pairs would be 1 s orbital, 3 p orbitals, and 2 d's to make sp3d2. So when we're looking at water, what you do is you want to draw out the Lewis diagram, and I'll do that for you really quick so you can just see how you would count these electrons pairs. Okay, so we have water, and we know that we have 2 lone pairs here. So I'm just going to count these. This is 1 pair, 2 pairs, 3 pairs, 4 pairs. So since we have 4 pairs, we're going to start with an s. We have 1 s, and then we have 3 more pairs, which would be p3. So it's sp3 hybridized. Okay, so let's do this one. I'll draw it out for you so you can see it again. Okay, so we have P, Cl, 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 like that. And we're just counting around the central atom, so I'm not going to put the lone pairs around the chlorine because that's not important for this. We're just counting around the central atom. So it's 1, 2, 3, 4, 5. It's 5, so I'm going to have one S because I only have one S or one orbital in S. I have 3 P's. So how many is that so far? That's 4. And then 1 D. So it's sp3d hybridized. So all you're doing is just counting. And then sulfur hexafluoride. That's octahedral. So you just count 1, 2, 3, 4, 5, 6. So it's 1 S, 3 P's, and then 2 D's, and that would give you 6. Now, just to make sure that you were doing this correctly, if we have like another molecule like carbon dioxide, that's C, 2 double bonds like that, we still count this as 1. So this would be 1, 2. So this is actually just sp hybridized. Okay, so make sure that you're counting a double and a triple bond as 1 electron pair. Okay, so sigma and pi bonds are something also that you'll see in AP, but I want you to be aware of this. And this explains the bond strengths of single, double, and triple bonds. Okay, a sigma bond is where your overlap of orbitals is directly between 2 nuclei. And what I mean by that is, okay, let's say that you have 2 s orbitals. Remember, s is a sphere. So here's our nucleus. And we're going to have a sigma bond between another s orbital. Here's our nucleus. Okay. So this is the overlap between these 2 orbitals, and this is where the electrons would be. And this is in between 2 nuclei. So this bond right here is very strong because it's directly in between those 2 positive charges. You can also have a P and a P overlap like this. So remember, a P is a dumbbell shape. Here's a nucleus. Here's another p orbital. And then here's our overlap in the middle. So that's where the 2 electrons would be. And it's still in between 2 nuclei. And then you can also have an S and a P. So here's our sphere. There's our dumbbell, 2 nuclei. There's our overlap. So that's a sigma bond. It's in between 2 nuclei. A pi bond happens between 2 p orbitals. So, okay, here are our 2 nuclei right there. Here's our overlap, and here's our second overlap. And this is where the electrons are going to be. And it's not in between 2 nuclei. It's above and below the nuclei. So this is not as strong. Okay? Sigma bonds are much stronger because the electrons are in between 2 positive charges. Pi bonds are not directly between those, so they're weaker. Okay, so why is this important? Okay, sigma bonds can be hybridized. Pi bonds cannot. So this is why when you count your double and your triple bonds, you only count it as 1 pair because you're only counting the sigma bonds. Okay? A single bond is made with sigma bonds only. A double bond will have 1 sigma and then 1 pi bond. So this is just talking about where the electrons are, or where the orbitals are overlapping in the bonds. So a double is 1 sigma and 1 pi, and then a triple bond is going to be 1 sigma and then 2 pi bonds. So again, you know, when you were counting your double and triple bonds, this is why you only count 1, because you have 1 sigma bond in there, and the pi bonds don't hybridize. So also, when we're talking about bond strength, a single bond is weaker than a double bond and a triple bond. However, a double bond is not twice as strong as a single bond because a double bond has a pi bond in it as well as a sigma, and pi bonds are weaker. So triple bonds would also not be 3 times as strong as a single bond because those pi bonds are not as strong as the sigma bonds are. All right, and that pretty much concludes this, and I will see you in class.